Theorem 6.1. Theorem 6.1 says that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Let us understand what this statement is telling us through this diagram. We are given a triangle ABC in which a line parallel to side BC, so you can see a line DE which is parallel to BC, intersects other two sides AB and AC at D and E respectively. We need to prove that AD upon DB, so AD upon DB is equal to AE upon EC. That means the two sides are divided in same ratio. So let us understand the proof. Let us join BE and CD. So we join this BE and CD here and then draw DM, which is perpendicular to AC. We draw DM. This line DM is perpendicular to AC, this side. And EN, so we draw another perpendicular line EN to AB, which is perpendicular to this side AB. Now, area of triangle ADE. So we look at the top triangle ADE, which is given in green color here, is half into base into height. Now we can take EN as the height and the base as AD. So when we take AD as the base, EN becomes the height of the triangle. Recall from class 9 that the area of triangle ADE is denoted by AR, and in the bracket we write the name of the triangle ADE. So we can say that area of triangle ADE is equal to half into AD, taking this as our base, AD, into EN. EN is the height. EN becomes the height. Now, if you look at the bottom triangle BDE, and if we are taking BD as our base, then the height of this purple triangle is also going to be EN. The height will come from this vertex E and it will be outside the purple triangle since it's an obtuse angle triangle. So the height is going to be the same as of the triangle ADE, which is EN. So we are going to write similarly area of triangle BDE, the bottom triangle, is equal to half into DB, this base, into this height EN. Now we have got two results, this result 1 and this as result 2. Dividing 1 by 2 we get, and as you can see the heights cancel out and this half and half will also cancel out, and so what we are left with is AD upon DB, and that will be our result 3. Now we are bringing the result 3 here so that we can remember this. So we have area of ADE upon BDE is equal to AD upon DB, which is our result 3. Now looking at the top triangle again, and now this time taking AE as our base, DM then becomes the height of the triangle. And so we get area of triangle ADE is equal to half into AE into DM. You can see AE is the base and DM is the height. And now looking at the bottom triangle DEC, again taking EC as our base, and since it's an obtuse angle triangle, DM is the height of the purple triangle also, and it will be outside the triangle. And so if you might have to prolong this to see that the height is here. So now the area of triangle DEC is equal to half into EC, the base, into the height DM. Now dividing 4 by 5, we get area of ADE upon area of DEC is equal to half into AE into DM upon half into EC into DM. And as you can see, DM and DM cancels out, half and half cancels out. And so we get AE EC. And that is our result 6. This was our result 3. Now, note that triangle BDE and triangle DEC are on the same base DE. So if you look at the bottom two triangles, triangle BDE and triangle DEC are on the same base DE. They have the same base DE. And between the same parallel lines DE and BC. So we have two parallel lines and the triangles are between those two parallel lines. And so you can see if you take DE as the base, the height will become the distance between the two parallel lines. Similarly, the height of this triangle will also be the distance between the two parallel lines, and they are going to be the same. So the base is the same and the height is the same, and so we find that area of the two triangles are also going to be equal. We will take this as our result 7. And now if you look at result 3, 6, and 7, the bottom triangles are also equal now. And the above triangle is the same triangle ADE and ADE. And bottom triangles have equal area. We will conclude that the ratios are equal. And so we get AD upon DB is equal to AE upon EC.